operations with functions. So here I just want you to see some notation of how functions can be added, subtracted, multiplied, and divide, and just get familiar with different ways that the questions can be asked. So you can see in this first sum line, it says parentheses f plus g, close parentheses, and then it has an x. Now, you may want to jump to thinking that you are multiplying these together because that x parentheses is by itself. This is just a fancy way of writing f of x plus g of x. So for example, if f of x is equal to 2x and g of x is equal to 4x, we're just adding those together. F plus g of x is 2x plus 4x, which is equal to 6x. So there is no multiplication there. Where we do see a multiplication is down below with our product, and notice the notation. We have f dot g. That means we're taking the f function and we're multiplying it by g. One that you have to be careful with is the quotient, where we have f over g. And the reason I'm saying that you just want to be careful is if we have a function that is irrational. So with a division question, I'm just recommending that you be careful and you separate it and rewrite it horizontally. So you can write this as x squared plus 1 over 2x plus 3, and then write divided by x minus 1. Then you can multiply by the reciprocal. So x squared plus 1 over 2x plus 3 times 1 over x minus 1. So just don't forget that those are properties that you're going to have to use when simplifying these functions. We're going to focus on composite functions, also known as composite functions. It can be said either way. Now what I want you to notice is the notation. The O in between the F and the G is an open circle. This is not a multiplication. So what this means is that we have one function that's actually inside of the other function. So this is another way of writing the composite function. The f is first, so it goes on the outside. The g is second, and it goes on the inside. The composition is the result of one function being used to evaluate a second function. So in this case, we're using g of x, the inside function, to evaluate f of x. Let's look at an example. So here's our example. F of x is equal to x squared plus 1. G of x is equal to x minus 4. Determine the composite function. So we're going to first rewrite this, f of g of x. Then what we're going to do is we're going to take g of x and we're going to replace it with x minus 4. Since g of x is equal to x minus 4, I'm just substituting it. Now we've seen questions like this all the time, where we have the function and then some sort of expression. So the next thing we're going to do is we're going to take x minus 4 and we're going to plug it into the f function. Here is the f function. We're replacing that with x minus 4. So x minus 4, x and x. So we'll put x minus 4 on the other side as well. And then we'll expand. That means we have to FOIL. We get x squared minus 4x plus 16 plus 1. We collect like terms. And that's our final answer. So we're using the function of g to evaluate the function of f.